I would like thanks all the organization to invite me here, and sorry for the technical issue. Today we'll talk about the hard contact lens from the history and through clinical overview. We know the hard contact lens here in Saudi Arabia had a large amount of practice because we have a lot of amount of keratoconus patients here in Saudi Arabia. So we'll start history for contact lens in the beginning. So starting from the history, the idea of contact lens actually starting around 300 years or more by Leonardo da Vinci. He was the first one had a concept of contact lens. That was in around 400 years. Second of that, British astronomer Sir John Herschel started practicing the lens design or contact lens design. In 1887, the first contact lens manufacturing from glass was be fitted in the eye. In 1939, contact lens first made from plastic. In 1948, plastic contact lens designed to cover only the cornea. And before that, they was put the lens like impression. They put it inside the eye, then send it to the lab and make manufacturing, then send the contact lens again. Long process. In 1971, the first soft contact lens was launched. In 1978, the first GB or gas beryllium contact lens was launched also. In 1981, FDA approved for a new soft contact lens for extended overnight wear. And in 1986, overnight wear of GB contact lens became also available. In 1987, the first disposable soft contact lens, and in 1887 also GB contact lens available in next new material, fluorosilicon. This is a new generation of material. In 1986, introduction of one-day disposable soft contact lens. Continue of the story of the contact lens history. 2002, silicon hydrogel contact lens first market, and in 2002, overnight orthokeratology approved by FDA. In 2010, custom manufactured silicon hydrogel contact lens was available also, and in this year, a new material called Hypergel by Bosch & Loeb launched this year. So we'll see the history. So contact lens is long away, and from this history we know the types of contact lens is soft contact lens and rigid gas beryllium contact lens, GB or RGB contact lens, and hybrid contact lens, soft and hard. Here is a table to compare between the GB contact lens and soft contact lens, and the things some patient doesn't know and some practitioner also doesn't know, the GB contact lens is more comfortable than the soft contact lens. I mean, in initial comfortable, maybe the soft contact lens be better, but in the long term, the comfort is more in hard contact lens or GB contact lens. And you'll see also the benefit of the visual acuity is more sharper in GB contact lens, and oxygen delivery, and also the duration of the contact lens. So here I think the GB contact lens is healthy choice for the patient. So we'll talk a little bit basic optics of contact lens. Even the contact lens plus or minus power, we have a good retinal image introduction by the soft contact lens. So, for example, if we have a contact lens magnifier 1 minus df, d it's a vertical distance. So, this example, we'll say plus 10, it's equal 0.86, and minus 10, it's equal 1.4. So the hyperbolic patient experiences smaller image size than the spectacles, and also in myope patient experience larger image size than the spectacles. So that's why we said the vision in the contact lens is better than the spectacles. So here, why the contact lens? Contact lens can manage a lot of cases and disease, like trauma, or we see this almost damaged cornea, we fit it with the scleral contact lens. Also with the systemic disease like Stevens-Johnson syndromes, we put the scleral contact lens for make the cornea moist all the time. And more aggressive and the bad viral, here we fit it with the scleral contact lens. So we have a lot of options to manage the cases and planning for the patient. So we'll talk about a little bit about the hard contact lens or GB contact lens fitting. So we're starting with the history. It's very important. Why the patient came for contact lens? Did he tried before or not? Any experience the patient was had it before he come to the clinic. We need to do also the external examination, and when we put the lens, we need to do assessment, and the last thing is prescription. History, especially the key here is the new patient. New patient is very important to discuss with them the option of contact lens. Either it's referred from the ophthalmologist or he came directly to your clinic. So a new patient, we need to spend more time. We talk about the lenses, we talk about the options he had, and explain about the contact lens. How to use it, cleaning, started, complication, and the side effect. I think the key of success here, you spend more time with the patient, and after the prescription, you need also to sit with them, and they know to hear from you, not from, we had like experience in our hospital. We prescribe the lenses, send them to the medical education. The staff there doing a great job, really. But the patient need to hear from you, it's better. And he will follow your instruction step by step. History, systemic consideration. Some patients have like a systemic consideration like AIDS or cancer treatment or diabetes. So we need to take this in our background. If he had good option, or the good choice for him to use contact lens or not. Ocular consideration. For sure, we can't give contact lens for active anterior segment disease or infection. So we need to finish the treatment of infection or the disease, then we can think about the contact lens. As Dr. Maden said before the presentation, we need to do a refraction for the keratoconus patient to know the best corrected vision, and also to know if the comparison between the corneal curvature of the case and the bowels for sphere and cylinder. So we need to do a recent routine refraction, and we notice also the back vertical distance. Of course, we need to do a full eye examination by slit lamp and corneal topography as well. K reading is an option also, but for me, I prefer corneal topography for two reasons. We'll talk about it. So the best exam all the structure of the eye by slit lamp. And when we do the slit lamp examination, I prefer to do the tear assessment, tear film break-up times test, as you see, to know if the patient had dryness. Maybe we can off the contact lens for a while. We treat the dryness, then we start the contact lens. Sherman test. And the corneal topography. Here, one image from corneal topography OBD. It's work with the system Lucido, so we can see the surface of the cornea. And also, I prefer a corneal topography than the keratometry. Than the corneal topography give you an image or like a corneal profile, so you can think about the base curve and diameter also before you starting the fitting. This is another example from Pentacam. You see the cornea here. By the way, this is not keratoconus, this is a trauma, but we will see inferior stiffness here in this area. So from this map, I will start thinking about large in diameter, very large diameter. And last year, there are a company called Midmont present a software programming put a virtual image for the contact lens inside the eye. Symbol of this program or software is take a corneal topography and take the parameter for the contact lens, and here this is the tear film and fluorescein button, and you can do the fitting from here, changing the button from here, and you'll see the lens and the other side is virtual image. So you can imagine how will be the lens after you do the fitting. This program is very good and excellent, really, but you need a quite good experience to starting with this program. So before we going to the fitting, we will talk a little bit of terminology here. So this is the hard contact lens. As we see, we have a front surface and we have back surface. Front optic zone diameter, and we have back optic zone diameter, which is called it by BOZD, which is called by base curve sometimes. And we have total diameter, TD, and we have the peripheral radius. We need to know also about the central thickness. It's very important, especially if the patient high power, like plus or minus. So we do the topography or keratometry, and we need to start with diameter. I think the position of the lid is very important. It's give you a good, either the fitting is good or the fitting is excellent. They are different between good and excellent. So the mechanical of upper lid, it's pushing down the lens every time. So you try to avoid this mechanical power from your fitting. So if the upper lid is low, try to make the diameter larger. And if the upper lid is not supporting very well, try to make the lens smaller. And lower lid, it's play a role, but it's not that much. But you will consider also the lower lid to in your fitting to have a good or excellent fitting. I simply that in early keratoconus, you can start with the large diameter. Why? Because there are no cone, actually, it's a beard, and almost the surface is, I said not regular, but irregular, but you can start with the large diameter to cover the whole area of keratoconus, the cone I mean. In moderate keratoconus, you can start with medium diameter, like 8.6 or 8.7. In advanced keratoconus, usually I prefer to start with the small diameter only to cover the cone shape. For lucid margin degeneration or post-surgery, usually start with a larger diameter, more than 9.8. So heights of curvature or base curve or back optic zone radius, it's depending on you what choice you starting with. You starting with the steep K and go 3 step later, or you starting with the K, the steep K itself, or you in Pentacam you use the mean of the K. It's depending on you. But the first choice you put it in the lens, it's give you a good idea what next you will do. So after we put the lens and put the fluorescein, of course, we will see 3 situations. The first one, a good fit shows a good lens centration with the lens part holding the lens, slowly dropping down, but it's okay. Also, the normal lid will give you the good movement in the periphery, so the lens is not moving in the periphery a lot. Alignment of the fluorescein pattern shows slightly apical clearance in the center, and in the mid-periphery, a heavy touch, and the edge clearance of 0.5. And we will see this image. You see here the good clearance in the center, almost by 7 milli, and we have in mid-periphery here a good touch. This is 0.5 clearance alignment, and we'll see this upper lid push the lens a little bit down, and we have good support here from the lower lid, and this is what we call optimal fit. This is give you a good visual acuity, actually sharp visual acuity, and also initial comfortable for the patient. By the way, this image taken by iPhone. A flat fit. We know the flat fits will be a central back area apical touch in the center. In the flat fit, the vision will not be distorted very much. Some patients have a good vision even with the flat fit, but it's not a stable vision because when he blink, the lens is moving. So this is what we call the black touch in the center and heavy bearing here in the mid periphery, and you see good clearance in the periphery. But don't confuse about the black touch here and bubble. Sometimes in the steep fit, as we see next, the good bubble, so it will be sometimes confused. In a steep fit, we'll see the opposite, the flat. We'll see the heavy central pooling here. Sometimes if the lens is very steep, we'll see bubble inside. The bubble is not moving, and you will notice that the lens is also not moving. So that's a picture of a steep fit. Also here with the steep fit, we'll see a very heavy black mid-periphery touch and quite good clearance in the periphery, but the center is very steep. The steep fit usually affect the vision and reduce the vision. So try to avoid the steep fit. Sometimes I use it in the clinic. I fit the patient with steep fit at the beginning because the steep fit is make the lens little bit, the movement is less than the optimum or the flat lens. So in initial comfort, and if I want the patient starting comfortable with the hard contact lens or GB contact lens, I can start him with a steep fit at the beginning. So here a basic rule for fitting relationship between the back optic zone diameter and back optic zone radius. So an increasing in diameter by 0.5 will require flattening the base curve by 0.05 millimeter. On the other hand, decrease in diameter by 0.5 will require also steepening the base curve by 0.05. Back optic zone radius and power. So when you make the lens is more steep, you need to add more minus power. And when you make the lens flatter, you will need to add 0.25 more plus power. And here, this is a table. We'll see here all the cases, what we said before. Here we have a flat fit, as you see, in the center black, heavy touch in the center with lifted edges. We can try to steeper the base curve, or we can make the diameter larger to make the fitting optimum as we can. And the steep fit, central pooling in the center, we can try to flatten the base curve, or we can try to small the diameter to make the fitting optimum. In optimum, we need to do anything. We have some condition like we have good touch and good clearance in the center, but the edge is very tight, so we can make the edge flat, or we increase the edge by 0.5 milli, or as you can measure it in the clinic. And the flat edge, we see here, the edge here is lifted, especially inferior, so we need to make the edge decrease or steeper. So we'll move to another part of the rigid gas premium lens. It's the material, which is we have a huge number of materials. So when you make the lens, think about the material also, because here in Saudi Arabia we have very dry weather. So try with the material with a very high decay over K. So when you make the lens very high decay over K, the lens will be fragile. Fragile, it be broken sometimes when you squeeze it. So put this in your mind. So this is a table. We have a different material, the brand names, with the oxygen decay per unit, and we see here for example, Boston XO is the highest decay over K, it's 100. And the thing is, I see a lot of prescription here in Saudi Arabia, Boston ES, which is 80. The problem here is not with the initial comfortment. The problem here after the wearing time. So the patient come after 5 hours, he suffering from dryness, and he told you I can't wear the contact lens more than 4 hours. So think about to change the material from this low decay to a little bit higher decay, or maybe more higher, like Boston XO. Another material brand here in Saudi Arabia, like fluorocarbon, it's very famous here, and Optimum Extra, and Paragon as well. It's a very famous materials around the world. So think about the material the patient he need after you finish the fitting. Prescription. Usually when you write a prescription and you send the patient to the optical shop or to the company, try to write the design or the brand name, because we have a lot of designs and brand names, so it will be changed from design to design. So it's, for example, you can't write the prescription, you fit the patient with the Rose K and the prescription is Kerocon, for example. So write the brand name, the lens, use it in the fitting, write it in your prescription. You need to calculate the power. The power here is very important because all the keratoconus patients using a spheric contact lens, which is a spheric contact lens just coming with the sphere. A spheric contact lens, a GB spheric contact lens may come with the cylindrical power. So all the keratoconus designs in Saudi Arabia is aspheric. So the power, you need to write it only the sphere after the calculation of the patient distance if the patient has high power. Base curve, either you write it in millimeter or in diopters. SAG, this is for the scleral contact lens. Diameter, Optic zone is very important because you can sometimes solve some problems with the back optic zone, like dumpling in the contact lens. If the fitting is good and you have small bubble inside the lens, you can make the optic zone larger and you can fix this. Also, if the patient complains of the glare, you can make the optic zone larger. Lens material, as we said before, the lens material is very important to know the amount of decay the patient he needed. And lens solution, the good things here in Saudi Arabia, you have only two types, the lens solution, the Boston and GB. But you need to make sure the patient he used the contact lens, GB contact lens solution. Don't ever told him to use the soft contact lens solution because it makes the lens dirty and a lot of deposit and starting complaining of dryness and sometimes of allergy when he use another soft contact lens solution. This was a brief about the hard contact lens. Thank you very much.